In these small sections, let's take a look at the type 3 of the indeterminate problems. The features of type 3 is similar to type 2, but only different from here. At the lower end, there's a gap between the structure and the constraint. If the loading would be small enough, then the deformation wouldn't close the gap. However, in certain situations, if the loading is big enough, the gap will be not only closed, but also the deformation will keep pushing the constraint to produce the reactions. So that come to the indeterminate problems. So we'll look at this problem here. So that is the same problem being exercised in the previous section, the type 2. And in type 2, we have calculated the deformation for this both constraint is 1.5 millimeters. And again, the role of the reaction is to push the imaginary deformed shape back into the original where the end-B state fixed, no displacement. Okay, so from this statement, we calculated RB equal to 50 kilonewtons. Now, how about this? If instead of being fixed here, we allowed the 1 millimeters, and here we have P, the same loading of P. So what happened to these structures? Again, you can visualize the system is this. Assuming there's no gap here, assuming there's no constraint here, then the system will be free to deform by 1.5 millimeter. Okay, so again, if there's no such constraint here, the system will be free to move by 1.5. However, this deformation exceeds the gap, so this additional constraint. So here, let me draw this one here. This is the real the constraint here. So you can see the additional deformation 0.5 millimeter is not allowed. So in our model, that is where the reaction going to produce. This reaction is going to push back by how much? By 0.5 millimeters only to maintain such this end. Once touch, the B will move, will kind of stay here. Okay. So that is the difference between the two systems here. Okay, just like draw here. So let me erase this one, and so again, to maintain the end B at the constraint, the role of the RB is to push back by how much? The hole is 1.5 and this gap is 1, so the pushback difference is 0.5. Okay, so this is 1.5 and this is 1, so the pushback is only 0.5 millimeters. So that is the thinking process here. So by doing this, you should be able to solve for RB. So let's look at the previous example of the formula for RB here. So for RB equal to this one, and RB times 1.5, okay, so over EA. So under these situations, we can solve for is this RB times 0.5 meter plus 0.1 meter. So that's again PL over EA. This is our template. The L is the whole length, so that is the whole length is 0.15 meter. Okay, and E is a given Young's modulus, and A is whatever this given cross section. This one must be equal to right now is 0.5 millimeter. So from here you can solve for RB. Okay, so that is the one. And let's take a look at the more practical example here. So we'll look at the same problems, and we look at the same problems here. So for this province, and we've been previously exercised, and for this one, the delta L under this setting should be 5.6 millimeters. Okay, that's the one we've been calculated earlier. Sorry for the interruption, and we're back to here. So that is the previous one we've been solved for, and we know if they wouldn't have such a constraint, the delta L is free to, and the lower end is free to move by 5.6 millimeters. Okay, and then that is where from which we applied to RB to move back, to push back the same amount to maintain the end B at no displacement requirement. Okay, so 0.5, that's what we have. Now for this province, if we have a gap 4.5 here, then see what happens. So you see from our previous calculation, if they wouldn't have such constraint, then end B is free to move by 5.6 millimeter. However, because the constraint given here, so we should expect reaction force RB exists, and RB is to, the role of RB is to push back by this amount, maintain once the NB touch here will maintain there. So RB rho is RB times whatever the whole things, and that push back by 1.1 millimeter. So that is we formulated here. So from this equation, RB equal to 113. Okay, and again, what is the RB's calculations? The RB's calculations is using this portion here. Okay, using this portion, that is the formulations, and that is the same thing we did in the previous example here. So refer to the previous sections for the formulation of RB. Then again, the RB rho here, the rho is to push back by only 1.1 because of this constraint. Okay, so that is for these sections.